I'm Chris. I work at Twitter, and I grew up in Thailand. I came to the US a while ago. At first, I wanted to do a master's degree in human-computer interaction, and then I took information visualization course, and I kind of like it, so I ended up doing a PhD there. And after graduation, I moved to the West Coast and have been working at Twitter since. So what do I do at Twitter? There are different things that I do there. One is interactive.twitter.com, which is a public custom-made visualization for different events like the World Cup, Oscars, Game of Thrones, and other things. And I also open source some library that can be used for visualization, such as labella.js for placing label with an overlap or D3 kit. And I also help the data scientists and engineers at Twitter look at information about users, products, so they can understand the products better. But these are internal tools. I have another talk that will cover those things. So, what are we talking about today? We will start this with problem. Why do we do this? Well, we want to do problem first, not solution backward. Because if you start from solution, to be concrete, let's say you want to build a map, then you start doing whatever that can fit into a map, right? If you have a hammer, everything looks like a nail. Okay, this doesn't fit in a map, I will not do it. You should start with a problem. What do you really want to solve? And then you find the solution that fits that. So the problem we have today is, I want to know what the audience are talking about the TV show. You know that, well, people come to Twitter after or during the show, they tweet about something, there are a lot of tweet volume, but what is in there? What are they talking about? So the show in question today is Game of Thrones, which is based on the book series, A Song of Fire and Ice. Anybody watch Game of Thrones? All right, cool. I will try not to spoil too much, but there will be spoilers. So for people who haven't watched or doesn't know about it at all, this is a brief version of trying to explain how things happen in the Game of Thrones world. So there was a king, a pretty drunk, bad, fat king. He dies. And a lot of people in the city, well, a lot of noble house try to wage a war, want to claim the throne. And this was manipulated by the minor characters who want the big house to fight, and then they can gain more power. And the characters in these stories usually belong to a house, and they have logos and motto like winter is coming. And the common theme of this story is if you see a brave, honest, honorable characters, they die. But if you see an intelligent but crook, shady, or stupid character who know nothing, they will continue to live. And to make matters worse, this happened in one continent. Switch to another continent, there is a princess who was supposed to be the rightful heir to the throne. And the dead king I mentioned earlier killed her father, killed her entire family, and she somehow escaped. So now she's finding her way back, and she has dragons. So if you think it's not totally messed up enough, while people are busy killing each other, ice zombies, the White Walker, are coming from the north. These are zombies, meaning they don't care about anyone. They just want to kill everybody. And the only group who seems to care about is a neutral group called the Night's Watch, which kind of guard the border on the top. And they have like 100 people against, I don't know, millions of White Walker. So let's see how things go. Anyway, that's kind of the state of Game of Thrones right now. And as you can see, there are many characters, and anybody can die. And so far, it has been 6 seasons, 57 episodes. And in each episode, you see different storylines happening in different cities. And the character appear in this episode may not appear in the next one. So there are a lot of varieties in the storyline. It's not just one single storyline every episode. You will see different characters doing different things, and they have different connections. So back to our problem. We want to know what are people talking about. Now we have a problem. It's the time to generate ideas. What can we do? Maybe we can look at the common words that they talk about in the tweets. But people talk about pretty much random things. I guess nudity, killing will be common keywords for this show. But does that really tell you what you want? When you read a story, you want to know about the characters. right? So why don't we focus on that first? And we will start by, let's see how often people mention different characters. So with that, I will start doing some prototyping. So I pull some sample data from the Twitter API. Even I work for Twitter, I don't have to go to Hadoop first every time because it's slow. I can do something fast just to get a small data set so I can work on it. And I start doing entity recognition and counting, which sounds name complicated, but it's a very naive approach. Basically, I have a long list of strings of all the characters, and I just do string matching to the tweets. Because this is prototyping, I mean, nothing can go wrong. It's just, let's start with something easy and see what are the numbers we can get. So the way it works is we have a tweet, and then, okay, here's somebody mentioning Hodor. So that's one count. And at the end, we will have a data set that looks like this. We have names and then count. So if you see a data set like this, maybe we can do some bar chart to show the most popular characters in every episode. Right? So that's a good start. But we don't stop here, because when you play a game of this, you iterate or you die. Where to go from here? There are different options. One way is you can collect data for every episode. And this was work done by The Guardian and Google Trends. They collect the character that was searched about the most in every episode and kind of show the bump chart of like popularity, rise and fall. Or we can look at emotion. Now people use emojis a lot, right? Can we make some use of that? Because it's very expressive. When you see the crying emoji or heartbroken, usually someone get killed. So we can do something with that. And when you look at the story is not like Castaway that is just one character. Usually there will be interaction between different characters and they are mentioned in the same tweet. So we can look at those connections as well. And if two characters appear in the same tweets, we can infer loosely that there is a connection. So my goal here right now is, all right, within a single episode, what can we learn about the emotions that the audience have, and from the connection of characters, what can we see from there? So I upgrade my entity recognition. Instead of being a stupid string, now I start using more complex pattern matching regular expression, so we can match by name, and the last name is optional, or if they have alias, then we can match that as well, just to cover more. Because sometimes people just mention the alias, not the name. So now we have more data. We have the individual character counts and also characters that will appear together in the same tweets. And if you look at this, we also have emojis for each of that. Look at this, is actually a graph data, because you have characters that are nodes and the, yes?
Curious, like for the character, Jon Snow, you have 500 count. But
Oh.
links you have 1,000.
This is fake data, sorry. But thank you for pointing out. I will fix that next time. So yes, the node count should be always more than the link count. So we have a graph data, and the most common, well-known, and abused way of doing network visualization is do a no-linear diagram and force-directed layout. Does everybody know about that? Should I? Okay, I can just do a quick run to. So, thank you to Block Builder. Pretty useful. So the force-directed layout, as its name suggests, if there's a link between two nodes, we will do a kind of physics simulation to pull nodes together. And in theory, when you have a sparse graph, it works pretty well. You can see patterns. The nodes that are tightly connected, like this purple group here, will be pulled together, so you know that they are kind of close or related. And when you code this in D3, you define a force like wall force equal to D3 layout force. And you can set a few parameters, like the size of the canvas, and then you set the node and links and call start to do a simulation. So it keep updating. And then you add an event listener every tick to update the position of the node and link. So that's roughly how it works. So we tried this idea and boom. Common results when you throw things into a force-directed layout is a force-directed hairball. You have tons of nodes tightly connected together and you don't see anything great. So how should we deal with it? Perhaps we need to know why this happened. Right? One reason is there are too many nodes and edges. If you throw everything you have into it, somebody will be connected with another person in some ways. So we can set threshold for that just to get the big nodes and the very strong links. So the very weak that are probably noise can be get rid of. And then you can also adjust different parameters of the force to make the layout more tolerable. So with that, we get a slightly better layout here. But we still have issue, which is occlusion. As you can see, Hodor in the middle is blocking the view of the surrounding nodes. This is because the default D3 force layout doesn't care about the radius. So everything's here, although it looks bigger for us. For the algorithm, it's just one dot. So it thought that, okay, fine, they are different, they are far enough in my opinion because I only see a tiny dot. But when you draw a big circle of that, it's kind of overlap. So we can trick them a few ways to use the standard force layout. Like you can set the link distance to include the radius. So if you try to push the big node with from a small node, you can increase the link distance. And because link distance is a function, it doesn't have to be a fixed value. You can do that too. But then there are cases when if there is no edge between the two nodes, then you cannot use that hack. So what should we do? Well, I did some stupid things such as fix some node position, like pull some big ones apart. But first, it's not scalable. I have to do this for every graph. Second, it looks totally ugly. I think it just looks too rigid and forced. So we'll do a thing that is more direct, which is collision detection. We want to check, in addition to the default force-directed layout, that if two nodes collide, we will move them far from each other. So the way it works in the code is, so now this is the default force-directed layout. And there's a parameter called charge, which is how much each node hate each other, so it will stay apart. Like if I say this to 100, so it will push each other. But again, it doesn't know about radius. So you see some overlaps and it doesn't work the way we hope it will. So we will ignore this and set the charge to 0. And then every time there's a tick event, means that before we draw, we will update the node position to ensure that they do not collide. And the algorithm basically create a quad tree of nodes and traverse them, and for each of the nodes, look for surrounding ones, push them around. This is a pretty common search blocks on D3, I think, and you can kind of go into this function and copy and reuse it. So now the nodes do not collide. What should we do next? Well, we can do community detection just to see group of characters that are tightly related, so we can see the patterns better. And once we have that, we want the community, the cluster to be a part as well. So there is another example by my boss doc that explains how to do that. Like in addition to the nodes being far from each other, you can add extra gap if it is from different cluster. And to draw these regions, it sounds straightforward, but it is not. So there's a utility called geom.how, which will draw the convex how, basically a region that surround any set of points you give it to. But again, it thinks that the points are only x and y. There is no radius. So if you have a really big node on the outer, it will go out of the region like this. Look at Melisandre. So how do we fix that? We trick the algorithm by saying that, okay, you have a big circle, right? I will just expand that to 8 points and feed that to the same algorithm. Yeah. So it will draw a nice convex how that cover those areas as well. Now we cannot get it to work for a single episode. We will get more data. So this is where I go to Hadoop and ask for more data, and it doesn't cooperate like the North. So I have to rewrite the script because I was using a Node.js script just to hit the Twitter API. Now I have to rewrite everything in Scala. We have scouting library, which is on top of MapReduce, so we can hit the tweet archive from 6 years ago. Now, when we look at Hadoop, the question is often which part of the data you want to look at, because you cannot get everything. Like 6 years of data is just too much. So after every episode, how much data do we need? It can be a whole week, 5 days, 2 days, a day, or any arbitrary amount of time. A week. So we can do a wild guess and get everything, or we can be data-driven and we plot the time series first of the tweets about Game of Thrones, right? And we look at the graph, and most of the conversation happen within 1 day. So we only get 1 day of data. And now we have data for every episode. We have to do extra adjustment to make the visualization work for every episode. Because remember 6 years ago, people did not tweet as much as today. And if we have any hard code number, like, oh, the node count has to be more than 100. It works for today, but does it work for 6 years ago? So we have to make adjustment for those algorithms. Like in this case, I use percentage instead because it's more like normalized and works across episodes. And there is also the problem of transition, because when you have different episodes and you want to switch the view to go smoothly to the other one. But if we try not doing anything and just set it, it looks like that, yeah. So we need to fix that. First, it's very fast, as you can see. So force, the D3 force has friction parameter you can set to make things slower, but it's kind of like the other way around. Like you have to set it to be, well, low number to be very slow. But the word is friction, so it kind of sounds weird. Now, after switching episode, how do we make the transition smooth? The first thing is I store the old position of the object. And then I assign new initial positions. This is because if you don't assign new initial position, D3 will assign it randomly. And as you can see, it's like all over the place. So we can assign a new starting position for every character to make the simulation work better. Because we already did some community detection and we know relationship between different groups, so we can have a starting position like this. We start from, now we have 1, 2, 3, 4, about 10 groups. So I put the groups with the maximum degree in the middle, and then the rest just around the clock. And the same within each group, I put the node with the maximum degree in the middle, and then the other members around it. So they will not overlap and have like some space to work on. Because if you don't initialize it like this, if it ends up being in the middle and everybody hitting each other, it just like splash out on every side. And that's why we see that jumpy animation on the other slides. And then once I do that, I run the simulation without updating the SVG for n rounds, just to make the simulation a little bit more stable. And then we animate the object from the old position that we stored earlier to the new position. And after that, resume the whole simulation. For the nodes and links, it's pretty straightforward. We remove the old ones that are not there anymore. Like if the character appear in this episode but not in the next one, when you switch to the next one, it should fade out and go away. And then for the one that exists, it should move to a new position, and for the new one, it should fade in. So in the code, it's kind of like this. You do a selection on every node, do a exit transition, fade them out, and then for the enter selection, add a new node, but set opacity to 0, so they will not appear yet. And then do a transition, both changing the position and also fade in by setting opacity to 1. Now the crazy thing is the communities, because these are regions and it's a path. And if you make it do a default transition between that shape on the left to the right, it's pretty random. So if I change this, it kind of like looks weird sometimes. We want to make it smooth. So how do we do that? The default behavior, it will try to just interpolate from the existing point to the new points, but these are 2 points to 4 points. Then it doesn't work well because the other 2 points doesn't exist before. It doesn't know what to do. So this is caused like unexpected behaviors. But if we add some middle points in the middle, we do custom thing like from this big shape, let's shrink it to just a circle region like this, and then from that expand out in this episode. Look at Daenerys here, Jorah. So it's less jumpy. And the code, instead of saying path attributes and just set it to a new one, you do a custom transition in there. And another thing I tune in this revision is the colors. I start out with category 10 because that's the default, it's easy. But it provides a distinct color, but when you look at it, it feels a little bit abstract because the color doesn't really mean much other than these are characters from different groups. But if you choose a color to represent something in the story, like use black to represent the Night's Watch, blue for the North, red for Daenerys, and gold for the Lannisters, when you look at the visualization, it has more context in there. And we have been working on the width most of the time, but it is not the only thing that we should focus on for work to be done. Because if you have only the width, this is how the whole page is going to look like. We need to add legend to explain what are the colors. And then I start adding navigation so you can change between episodes. And to make simple question like what are the most popular character in each episode, we can add a table like this, as well as list the most common emojis for them. So we can get an idea how people feel about Hodor in this episode. And yeah, I think this one is when Tyrion drink wine and say something cool. So that's why the red wine emojis. And we can also have some advanced control because I was filtering by percentage earlier. If somebody want to change that, they can do so. And by looking at this, you kind of start to get some idea that there are different group of characters, and if you watch a show, this kind of correspond to different arc of the stories, like Jon, Sansa, and Littlefinger in the middle, up to something in the north. Hodor and Bran escaping the White Walker, and Hodor was and Daenerys is doing something else. Now we want to know what exactly happened, so I want to provide just an actual summary. So I went to Wikipedia and just copy paste this text for every episode. But to make this more useful, because when you look at Hodor, you don't want to read the whole text, right? You want to know only the sentence about Hodor. So when you mouse over Hodor, I will filter only sentence that contains that character. So you get a summary of what happened to each character in this episode. And you also get a tooltip that provide additional information, the most popular emoji, and like compare to previous episodes, how often this character get this much attention. As you can see, for Hodor, it's only this episode that he got 40%. The rest, he was just minor character walking around saying one word. Well, so you can go to the demo a little bit. Well, you watch the latest episode, right? You can start from like some simple. So, oops. What's happening? So we can start from the earlier season. This is when the story wasn't that complicated. The character doesn't have much connections. And if you remember the first season when these two siblings were doing something in the tower, that was the first episode. Yes. And then once you start like going along, the characters like change, and notable episodes such as the Blackwater. So there was a war, and the scene mostly Tyrion in the battlefield trying to fight Stannis Baratheon, and Cersei Lannister is hiding in a room, afraid to be killed. So there are a lot of things to explore if you are fans. You can just like scroll through and see different stories, and even something not in the story. So this was from this season. There's this strong connection between Tommen and Brienne. There was a scene when these two kind of show some glimpse of romantic interest, and Twitter just went crazy about it, make parodies, jokes. So you see a lot of hearts. Yeah. With that. And it's also work on mobile. I even forget. So on mobile, the tooltip doesn't work the same way. It will kind of cling to the bottom, so it will not occlude the view. And when you tap it, it kind of stay there, as opposed to like going away on the big screen. But this way, any audience can see it, although it's not a full experience as good as the big screen, but they can still come and see something. And once I put this thing out, we need to evaluate it because feedback is the breakfast of champion. the first thing before we put this thing out is we ask ourselves, does it solve the problem that we aim for in the first place? Does it tell what the audience are talking about in each episode? And by giving this to my colleagues just for trial and let them play with it kind of do that. So we think we tackle it in the right way. And when we put things out, we have logging, Google Analytics, just to look at page view, how many people come to see it. We also add custom events, like when you move the slider or change the episode, there's custom event for that. So at least I know that people didn't just come to see the first page and they didn't look at other episodes at all. Then I waste my time doing this whole thing, right? So I want to know that people do that. And we can also look at referrals and just go to see where are the traffic coming from. And I track one of the forum and I see this comment. So, well, I count that as a compliment. Then, well, if I can trick someone to play with it 30 minutes, I guess I did a good job. And some of the news publishers also think the same way. So stepping back, like when we do a piece like this, I will try to think about how can we reuse this for other concepts, right? So what are the advantage and disadvantage of the thing I just put out? Well, the good things is the only input we gave to this visualization is we give tweets and the regex of characters. The algorithm doesn't know anything about relationship between characters, the plots at all, but it can still produce this useful visualization. So it is very lightweight. It doesn't demand a lot. You are not doing a very complex model. So if you want to apply this to another show, then it's pretty straightforward. But of course, because it doesn't know anything about the plots or characters, sometimes it tries to group characters that are not supposed to be next to each other in the graph. Like they are on different continents, they never know each other, but the algorithm doesn't know that. And this creates noise in the visualization too. So this is where the talk must end. Just to sum up, I start by saying that we start with problem, not solution backwards. And with that, we prototype with different ideas, iterate, start from one episode, getting more information in one episode, how to make it work for one episode. And then once we have multiple episodes, what are the extra things we need to do to make it still work and have a good experience? And not just the width part that we focus on, but also the whole experience of the page. And once we put things out, we want feedback so we can know what did we do right or wrong and improve. And there's always room of improvement for this. Like the regex, we can do a more sophisticated machine learning or NLP to do character detections, and we can feed a lot more information into that just to make this more precise. With that, I would like to thank you, people who helped me on this. And my team is hiring front-end and data scientists, so talk to me if you're interested. And with that, I end the talk here, and we'll be happy to.
How long will it take if they give you a content?
This one, I think 2-3 weeks. Yeah. Well, getting the first prototype is not hard, but then I spend time on those transition and details. I think the last 5% of every project is always the hardest.
So each episode, how many data do you roughly pull? This should be a
one day after it airs.
But
How many tweets?
millions of tweets.
So when we read this, we read the whole day of tweet and then filter by keywords related to Game of Thrones. I don't have the number here, but we have to read everything, but filter down to only things about the show. But Game of Thrones is probably the most talked about show, so it's a lot of data.
Another question about the interactive side. Do you make API code each time you change episode, or you already have?
This one, no. This one is small enough to be in one file, so it's faster. But yes, if the data is much bigger, then we probably have to have one file for each episode.
When are you going to do House of Cards in Silicon Valley? That is reasonable.
I'll keep it in my pocket though.
I was going to suggest a vote for the White House.
Yeah, well, there's also a part that kind of labor intensive that I didn't mention much is listing all the name of the characters. So I did that manually myself, but because I watch a show, so I'm willing to invest.
When you say 2-3 weeks, do you mean like more than 100 hours?
So when you work with Hadoop, there's always a wait time. So I switch to do other project like while waiting, and then when it comes back, okay, it's wrong. Let's rerun again.
Actually, for each episode, right, you say you pull the 1 day Twitter data, then you do the summary, get all those connection links, right? You have roughly, for each episode, in 1 day, how many tweets you have?
Oh, well, I need to check the number to be sure. I don't want to give out like a number right now because I don't have it on the top of my head.
1,000, 100,000, 10 million.
Well, on the show day, it could be million.
Okay, that's big now.
Oh, okay, you manually just pull the US trade data, right? Is it like the episode showing on HBO, then people start trading?
Because it's just 1 day, it could be a tweet from around the world, not just the US. So after the episode air in the US, we do a window of 1 day and it also air on somewhere else. Yeah.
What do you think is the most difficult part for this project?
Let's see. Well, I think there are a lot of doubts in the beginning because I already get rid of many bad screenshots. Like when I start throwing the data in and first it's a hairball, I know that it's going to happen and I start cleaning, but it's still not getting there and I have to try, like before using community detection, I play a lot with link distance and remember the fixed position and those crazy things that doesn't work out well, and I don't see the pattern much, but after getting to the point that, hey, the community detection kind of works pretty well and I start to see different story in each episode, I have hope and I continue from there. But like the first part is a lot of doubt because this is the first time we do something like this too.
So you get the data from Hadoop, like a million tweets. You store them in some intermediate database?
Oh no, we process it and then we just output the count. Yeah, so we run MapReduce, just get that through if this tweet is about Game of Thrones or not. If not, throw away. If it is, what are the characters inside? So instead of a whole string, you have an array of character ID.
Is this sitting in a text file or in memory?
Well, Hadoop is a big chunk of text file. Like, yeah, it's read text and just count text.
Can you talk about showing the emoji on the node labels? Is that just a second row or a span? How do you show that?
Oh, that's another text. Like I have, so it's a G, and then there's one circle, another text for the character name, and another text for emoji.
So SVG text?
Yes.
Have you thought about like analyzing emojis across the whole series to see like the saddest?
Yeah, actually, my colleagues is pretty interested in like doing kind of sentiment model based on emojis because we can see from this that it's pretty rich. People use crazy emojis, and like yeah, it's very expressive. At first, I thought it would be like smiley face, crying, those kind of things, but we start seeing bears, lions, and the red wine.
I think this is more about how the movie is reflected in the audience rather than the real relationships within the movie. Because what you do, you extract what they are talking on Twitter rather than what's going on.
Yes, we want to know what they are talking about, and most of the time they will talk about the story that happens, but we also see the connections that are kind of in their mind. Like when somebody did something cruel, there will be a link to Joffrey. all the time. Like Ramsey is linked with Joffrey pretty often. Those two characters never met in real life.
Why would that like that be interesting for Twitter? What's your interest in this kind of data?
Could you repeat the question? I didn't hear the first part.
What if Twitter want to know the emotion about the character?
I think the whole piece is more about trying to tell people that there are a lot of interesting conversation happening on Twitter, and one way to show that is to summarize and get an idea of these are what the people are talking about, and there are different aspects, right? There are the storyline, people talk about these characters, connection between them, and also how people feel about these characters, and maybe you will feel more related to that because you feel the same way. I don't think at the moment. Yeah, this is more like fan gift kind of.
Can you talk a bit about how you look at interaction with individual pages? Do you have analytics to see where people go once they visit the homepage, if they go to a certain episode or the most recent episode?
So I use the events in Google Analytics, and when they change the episode, it so pass the parameters that is the episode ID, and from there you can do like funnel things. Like after they went to this episode, do they do this and that?
You know, were there certain episodes that were really popular?
The obvious one is the one they landed on. The previous one, people jump to the first episode a lot.
Really?
Yes, and in the middle are kind of random, and I think some article wrote about particular episode, and we have deep linking, so they landed on those episodes.
Was deep linking, it wasn't difficult with this, it was just setting which episode?
Yeah, so just read from the URL params and set the state. That's not bad.
What's the maximum number of nodes you had, or what's the largest?
Well, I haven't count, but it's pretty small relatively because we filter. Oh, we cap it at maximum 50 nodes.
Could I ask you briefly about how you found the communities, how you drew those groups?
So I use a community detection algorithm. It's open source also. Vein. Yeah. And another area to explore is there are many community detection algorithms, and it doesn't mean that this one will work the best. It's just like available, and I grab it and it kind of works okay. But it would be nice to try different ones and see which one works best. Like there's a whole Wikipedia article on different algorithms you can try.
Yeah, thanks so much.